So students, this is question number 1 of paper 1 of physics JEE Advanced 2022. So this question says that there are two stars having density rho A and rho B, and they have the same radius and their masses are given like this. So let me draw this information that we have right now. So the radii are same. If one has mass if A has mass m, then B will have mass double of A, that is 2m. Okay, the radii of both are same. Now, due to an interaction, A loses some of its mass so that its radius is halved. Now, A has changed to something else such that its radius has become half. Now, earlier, if its radius was capital R, it has now become R by 2, which would mean that the mass has become m by 8 because the mass is proportional to r cube. So if radius has become half, mass will become 1 by 1 by 2 cube of the previous value, that is m by 8. Okay, so and while its spherical shape is written, the question says the density of A remains same. The entire mass lost by A is deposited as a thick spherical shell on B. Okay, so the B was as it is, and the mass that was removed from A has been deposited on B, keeping the density same as A. All right, so keeping the density same as A. So if I represent A with green color, like if I use green color to represent its density, so here we have used the same density. Okay, and I'd use a different color to represent density of B because it had twice the density as compared to A. So let me use blue color to represent its density. So this is the scenario. Now this would also mean that the radius of B has now become more than R. It has become something like R plus delta R, where delta R is the thickness of this layer, this particular layer that we have now deposited. Okay, now the question says that VA and VB are the escape velocities from A and B after the interaction process. All right. So that means that VA should be written as root of 2gma prime, where ma prime is the mass after the interaction. Okay, divided by the new radius, which is r by 2. Similarly, VB should be written as root of 2gmb prime, where mb prime is the mass after the interaction, divided by the radius after the interaction, which is r plus delta r. Now here, let's clearly write the value of ma prime and mb prime. Ma prime is already written, it's m by 8. What about mb prime? Mb prime will be equal to the previous mass, that is 2m, plus m by 8. So this will turn out to be 7m by 8 actually, because this layer, the m by 8 mass is there, so the lost mass is 7m by 8. So 2m plus 7m by 8, so it will become 23m by 8. All right, so now if I take the ratio of VB and VA, okay, what happens when I take the ratio? Let me cancel out things which are going to get cancelled. So they would be that 2g, this is going to get cancelled. Okay, and when we are writing VB, so MB prime will come here, MB prime, and r plus delta r will come here. Okay, and then into we are going to have r by 2 divided by ma prime. All right, so I will now put the value of mb prime, which is 23m by 8, and here I'm going to put the value of ma prime, which is m by 8. So this, and apart from this, we are going to have r by 2. So there is going to be a 2 also here. Let me write it here, and r plus delta r. So this is what we are going to get. And I can see that m gets cancelled, this 8 gets cancelled, right? So we are left with root of 23 by 2 into r upon r plus delta r. So this is what we need to calculate now. So we will now focus upon calculating this value, like r upon r plus delta r, or rather I will focus on calculating the inverse of this. Okay, so let's not calculate this. I think the calculation of inverse will be a little bit easier. So I will try to calculate this and then I will put it in the previous equation. So it is going to become 1 plus delta r plus r. Okay, which we can call it as 1 plus x also, where x represents delta r by r. This I'm doing just for the ease of writing. Okay, now what I'm going to do, what is the plan here? So I plan to equate the density of these two, like this density and this density is equal. Okay, so the density of star A, or rather the density of star A remained same before and after the interaction. So before interaction, the density of A was mass divided by volume, that is 4 by 3 pi r cube. Okay, this was the density of A before the interaction. Now I'm going to write the density of this layer that has been deposited on B. And how do I write that? The mass of that layer is 7m by 8, and the volume occupied by that layer would be 4 by 3 pi, and then we are going to write r plus delta r cube minus r cube. Okay, this is what we are going to write. So if I begin to solve this, m gets cancelled, and 4 by 3 pi gets cancelled. What is left here on the left hand side is 1 by r cube, and on the right hand side we are left with 7 by 8 divided by, let me pull out r as the common quantity, so we will end up writing 1 plus x cube minus 1. Check this out, guys. Okay, so this is what we will end up writing. So I can now cancel r cube also, so this will give me 1 plus x cube minus 1 is equals to 7 by 8. So this will become 1 plus x cube is equals to 15 by 8. I'm taking this one on the other side and I've done the calculation. So this gives me 1 plus s x as 15 raised to power 1 by 3 upon 8 raised to power 1 by 3, which will become 2. So I've obtained the value of 1 plus x, and here if I check, so this is nothing but the ratio that we were trying to calculate, the ratio of VB and VA. It was root of 23 by 2 into 1 upon 1 plus x. All right, so we'll substitute the value now. So 23 by 2 into 1 upon 1 plus x is like 2 upon 15 raised to power 1 by 3. So this becomes 23 upon 15 raised to power 1 by 3. Now if I compare it with the given expression, this expression, then basically I discover that this 10n is representing 23. I discovered that 10n represents 23, which means that n represents 2.3. So that will be the answer to this particular question. I hope you enjoyed the solution, guys. Thank you so much.